am Morgan Bell, the social media manager here at UAF, and I am with Melissa Ward-Jones at AGU, and she's going to introduce herself and talk to us more about her poster.
Hi, I'm Melissa Ward-Jones. I'm a postdoctoral fellow at the Water and Environmental Research Center at the Institute of Northern Engineering at the University of Alaska Fairbanks.
Thanks, Melissa. Do you mind telling us about your research?
So my research is looking at ice wedge systems. So ice wedges are a really common type of ground ice that we actually see locally in Fairbanks, but also kind of everywhere in the Arctic. Because these form from thermal contraction cracking. So when the ground gets really, really cold, the ground surface will crack. You'll have water that infiltrates and then freezes with the frozen ground. And then you'll have ice accumulation over time. And so if you can think of like a spider web, wherever there's webbing, that's where the ground ice is. So it creates these polygon systems. And so my project is focused on quantifying these microtopography differences within ice wedges, and then collecting field data, and then applying field measurements to the microtopography to kind of quantify these microtopography relationships.
Awesome, thank you. Do you mind explaining the impact of this locally and globally, and why it's important to study this?
So this is important to study because ice wedges occur everywhere in permafrost environments, and we know they have a big impact on infrastructure, carbon cycles, vegetation. But they're so fine scale, they're really these sub-meter systems that we don't have a lot of data sets that are such fine scales to really quantify them and their impacts at these fine scales. So my project is aiming to do this, and then also looking at how these fine scale processes then translate to coarser remote sensing products.
Great, and it looks like this is a preliminary assessment. What future work are you going to be doing?
So this preliminary work, I show examples from two sites. So the Teshpuck Lake Observatory, which is located on the Alaska coastal plain, and also at Prudhoe Bay. So I just show examples of ground temperatures, but I'm also going to be looking at the relationships with snow depth, soil moisture, vegetation, health, and also carbon and methane fluxes.
Awesome. And you were talking about a PhD paper that inspired you to do this. Do you mind just elaborating on that a little bit?
Yeah, so my PhD, I did a paper in northern Canada where I was looking at ground temperatures and microtopography, and I was just blown away by the variability, particularly in the wintertime, how just these small differences in the ground surface elevation drove winter temperature difference of over 15 degrees. And I was so amazed by these results that I wanted to study this further, and then was able to get funding to look at this. And so, yeah, so this project is funded by some NSF, also National Fish and Wildlife Foundation, and then I got a NASA new Early Career Investigative Program Award that's really going to kind of take over and look at this really in detail.
That's so cool. Thank you for sharing, and thank you for looking into this important work, and thanks for being here with us today.
Thank you.